Wherever I stay, there's a feeling I'm so far away.
Hi friends, this is the second part of the Microservices tutorial and I wish that you have already seen the first part. Well, I continue with this slides. In this part, I'm talking about the scalability and comparison between a monolithic system from the perspective of scalability and microservice architecture. I think I discussed about this a little in the first part, but I continue here. As you see here, in a monolithic system, because all the functions are reside into a single process, and you have all the application as a monolithic system in one place. So whenever you decide to scale system, scale up or scale down, or doing some replication, you should replicate the monolithic system on multiple servers. For example, you have a WAR file or jar file for your application you have developed with, for example, Spring, Struts, or another framework like Play or JSF prime faces. So in this case, you should replicate your application across multiple servers. For example, you may need 4 servers, deploy your applications as a WAR file or jar file in all of those 4 servers, and then you can also implement a replication mechanism or load balancing mechanism, for example, using Nginx between these 4 servers. But in microservice architecture, the scenario is different because you divide your functionality into different processes and into different services. And in this case, it's very easy for you. You can scale up and scale down each services across servers independently and replicating them as needed. Also, you can use load balancing for your services, and uh, in another slides I will discuss about some different ways of load balancing. For example, you may use ribbon, that is a client side load balancing. It totally differs from uh, server side load balancing, for example using Nginx or some hardware for having load balancing. And so when you design your um, system based on microservice architecture, you can deploy each service in a Docker container, and I mean an individual Docker container, and you can uh, have a scalability by using uh, other third-party tools. For example, you can use Docker Swarm or Kubernetes from Google, and uh, implement some mechanism and some roadmap for your uh, scalability and scaling up your workers in a Docker Swarm. For example, in Docker Swarm you have some workers. You can scale up, scale down, or some workers may be ready to be going to up and running a state when another similar service is done. For example, you have 3 or 4 uh, nodes for your registration service in Docker, and in different Dockers managed by Docker. So when maybe you have at a given a period of time, you may want to have 2 of them running and load balancing between them. If 2 of them crash or went down, uh, the worker manager will up another one that is in a same group. So from the point of view the user, the system looks always up and running, and it seems very good. Okay, uh, in this slide I want to discuss about the persistent approach in microservices architecture, as uh, and discussing about why we should use polyglot persistent approach in microservices. And in other parts of the tutorial, I also discuss about having polyglot programming languages for implementing a microservice uh, architecture and microservice project, why we should use different programming languages and why it is suggested to use different programming languages for implementing each services. But here I want to discuss about polyglot persistent approach. And basically, it's not suggested by professionals and geeks of microservices that you use a single database. For example, using MySQL or MongoDB, Cassandra, Oracle, etc. for all of your microservices. Actually, based on the nature and essence of each microservice, it is suggested that you design it with a specific database related to the characteristic and the functionality of your microservice. For example, if you want to manage transactional requests that are related to user transferring money, credit cards, it's suggested that you design this microservice with a transactional database and RDBMS database like Postgres, MySQL, or Oracle, or SQL Server. But for example, if you have another microservices that the data are most of the times are schema less, and the write in that microservices is very high, and you have a high amount of writing in comparison to reading in that microservices, and you want those writes to be fast, real time. It suggests that you use NoSQL databases like MongoDB or Cassandra. And maybe in another microservice in your environment you have a microservice that is responsible for searching data. For example, users want to search a string, something in a very large database with billions of records. So as you know, RDBMS and some also NoSQL database are like MongoDB or Cassandra is not a suitable choice for real-time search. We have another category in databases, we call it search engine databases. For this case, in your microservice, you can use some search engine database like Elasticsearch or Solr. Both of them are based on Lucene engine, and they are very fast. You can search billions of records and it will respond at once and very fast. But I suggest you that when you want to choose between Elasticsearch or Solr, you should think about what is the what you want expect from your microservice. And if you want your system is very real time, data and schema change oftenly, it would be better that you use Elasticsearch. In this case, Elasticsearch is more than I think 50 times faster than solar. But if your system is not real time, data is not changing oftenly, it is suggested that based on the benchmarks that you can search in the internet, solar is twice faster than elastic. But concisely, in many scenarios and in many cases, Elasticsearch is better than Solar. Also, it has um, more functionalities, features than Solar for data mining, data warehousing, and it would be better for having better flexibility and functionality. You use Elasticsearch, but also Solar is a good choice in this case. And for example, in another microservice, you may have functionalities regarding social networks. In this case, it is suggested that you use Neo4j or another databases that have been inherently designed for social networks. Well, I think that's enough for this part, and in other parts, I may discuss about polyglot um, programming languages approach for implementing microservice architectures. In this slide that I have screen captured from, I think, Pivotal. In an overview, you see a Spring Cloud components that I will discuss about each part many times during this series of tutorials. Uh, as you see, and I describe here, the very most important components of a Spring Cloud are these ones. For example, discovery, service discovery, that I will discuss about service discovery, why you should use discovery and when using service discovery and why. And for example, Netflix has implemented and developed a very good service discovery called Eureka. Also, you can use other discovery systems. For example, you can use Consul, Consul, from HashiCorp for having service discovery. And also, config server is very important. I will discuss config server in more detail in another slide. According to the 2 factors, the configuration of your system should not be in your project. It should be separated into the environment, because having loosely coupling and adhering to loosely coupling principle, and your services, your project should not dependent to a config server in each service, or in your even in a monolithic system, in a single project, in a single process. And circuit breakers is actually very important. It's one of the most important enterprise integration patterns that in a very famous book, Enterprise Integration Pattern by Bobby Wolf and Gregor Hope. In that book and many other books written by geeks, all of them have discussed about circuit breaker, what is circuit breaker, and I will show you in other part of this tutorial, maybe even codes, how to use circuit breaker by using Netflix OSs. Actually, I give you a short description regarding circuit breaker here. For example, assume that you have a registration service and a recommendation service, and this service call each other using some REST API. For example, in recommendation service, you want call registration service to fetch the age of the user, or the rules, or um, other information regarding the user. So you issue a REST call from a recommendation service to the registration service by REST API, for example, a Spring REST template or other libraries like REST Easy, Jersey, or even Netflix Fame. When you call another service within your existing service or current service using a REST service, you will add a single point of failure. You will add latency. You will add delay in your system. So assume you may encounter different results when you call, for example, registration service from your recommendation service. uh, Imagine that your registration service is not up or not responsive or maybe very busy, having delay to uh, sending result back, and for having delay for sending response to the calling client. In this case, the calling client is another service. So in this case, you want, based on the nature and essence of the microservice architecture, you give the user the feel of this, that system is already always up and running. You don't want to show error message, exception, the system not working, something like that. So you implement a circuit breaker in this case that is a redundant way, is a workaround. I can easily explain it. I say it is a workaround. Whenever you call another service and it's not running correct, etc., the circuit breaker will be open and come into play and route your request to another thing that you are sure it's always working. For example, you always have some data that may be useful in that case for user, and instead of the REST call, you return as a response those data by using a circuit breaker to the user. And actually we have two type of circuit breakers. One of them is working based on timeout. Maybe you calling another service that within the 30 second, 20 seconds it is not responsive, and the circuit breaker will come to play and will be opened and handle the request. Or another case when the service is not up and running, not responsive, it's not working, without mm, without needing any timeout, the circuit breaker, when discover this the calling service, the called service is not working, circuit breaker will be opened and come into play. So circuit breaker, in a nutshell, is very important enterprise integration pattern. Well, um, another components, as you see here, are leader election. For example, you can use Zookeeper for leader election in a cluster environment, or some other framework, for example etcd, or we call it etcd from core os, for leader election in cluster environment. And for intelligent router or intelligent routing, you can use ZOL, ZWL, for intelligent routing, that I will discuss about this intelligent routing. It also can be used as an alternative for API gateway, for a proxy-based routing, for decision about the routing, which request should go to which microservices, and maybe you want also implement some conversion between the client API that calling uh, the service in different way, and your backend system, your services implemented in microservice frameworks, infrastructure, and it's related to its outer architecture of your microservice environment. And the edge service, also here in the edge service, you can use API gateway for routing the request to suitable services, and those in this layer you can have some for example, for making decision for proxy-based routing or uh, convergence between different type of APIs in client side and in your backend. Also, the bottom line, one-time token, global log, and cluster are very inherent parts of the Spring Cloud components that, for example, global access working with sessions, and it's make your life very easy. Instead, you'll be engaged to manage session, locking them, managing global states of your system. Spring Cloud will give you some ways to do it, and also doing some of them automatically for you. And in the event bus layer, uh, if you want to have something integrated well with Spring Cloud, I recommend you using Spring AMQP. Spring AMQP actually is an implementation of our famous message broker called RabbitMQ. I think that most of you already have heard about RabbitMQ. It's something like similar like ActiveMQ. In your event bus layer, I will discuss later on in this series of tutorial why you should use actually an event bus and what is the role of an event bus in an microservice architecture. And basically, here I give you an hint. Event bus is mostly used for event sourcing and communicating, transferring messages between services in an asynchronized way in comparison to synchronized way when you are using RESTful web services. So one option for event bus that is very good is Spring AMQP and RabbitMQ. AMQP itself is a messaging protocol. It stands for Advanced Message Queuing Protocol. We have other protocols like MQTT, Stamp, OpenWire, XMPP for transferring messages in a system, in a distributed system. Each of them with their own cons and pros. I have written an article in my LinkedIn website regarding comparison between different messaging protocols between MQTT, AMQP, or Stamp and OpenWire. You can go to my LinkedIn website, and if you was eager reading my article regarding these protocols. Another alternative for using event bus is Kafka. Apache Kafka is very good and capable of handling many transactions, many number of transactions and messages, sending and receiving messages in comparison to ActiveMQ and RabbitMQ. So Kafka is very good choice in the cases that you have high volume of messages that you should handle in a second. in a short period of time. Okay, and in this slide, this is an overview of the most topics I have discussed already. In other slide, you see here the suggestion for microservice architecture using Netflix OSS and Spring Cloud. Here we have a Spring Framework. In a Spring Framework, you may have different modules and libraries and even different sub-framework. For example, a Spring DI for dependency injection and inversion of control, a Spring Data for having an abstraction layer over your database, a Spring Batch, for example, a Spring Batch. You may have also here a Spring Batch and other Spring libraries and modules, a Spring Kafka, a Spring AMQP, a Spring Boot. As you see here, that I should mention here that the Spring Boot is very good for implementing your microservices based on a Spring Boot instead of, for example, a Spring MVC. Because as you know, when you are developing a Spring MVC project, you should mess with XML configuration, web XML, and it is mostly based on the configuration. But when you are using a Spring Boot, a Spring Boot is actually follow this paradigm convention over configuration. That is very good and make your development process very faster. And also because a Spring Boot support embedded web server, that is by default Tomcat. Also it supports provided web servers you can deploy in other web server, Tomcat, JBus, WebLogic, etc. Because this feature that it support embedded embedded web servers like Tomcat, Netty, Jetty, it's also very good for implementing your microservices based on Spring Boot. I discussed about Spring Cloud, and as you see here, Netflix OSS Eureka is for discovery purpose, and Historic is, as I described in previous slide, you can use Historic and its Historic dashboard for circuit breaker. You can implement some circuit breaker logic in your system, and by using Historic dashboard from Netflix, you can actually visualize and see your circuit breakers that are closed, open, and how many requests, how many percent they are rejecting, they are processing. That's very good. And as you see here, Zool is actually intelligent and programmable routing framework that you can use in your microservice environment. And Ribbon, I discussed a little about Ribbon, that is a client-side load balancing that has been devised and developed by Netflix. And in the right part of this slide, you see, for the sake of the overview, circuit breaker, service discovery. For example, service discovery, you can use Netflix Eureka. Configuration server, load balancing, for load balancing you can use Ribbon, and for API gateway you can use different kind of API gateways. For example, Netflix API gateway, Zool API gateway, or API gateway developed by Pivotal. Or even you can implement your API gateway from the scratch, but you should adhere to enterprise integration patterns whenever you want to implement your API gateway yourself. Well, in this tutorial, you see most of the things I discuss about them in the same place. Here, and as you see, excuse me, I want to, as you see here, it is like a help. You see that this color is actually a reservation application, that here we see a service called reservation service. These items are Spring items. For example, a Spring Cloud config server you have here that has been developed by Pivotal. Actually, these are Pivotal items. And this color, purple color, is Netflix items. As you see here, Netflix historic dashboard. I discussed about it in previous slide for circuit breakers, and Netflix Eureka server that you can actually use it for the purpose of discovery in your system, discovering of your services. Here, Eureka server as a discovery server is responsible for discovering this reservation service here, as you see. And the red one is the database. You have Cassandra here. As I discussed in the previous slide, it would be better that you go with a polyglot persistent approach. As you see here, we have different kind of databases. Here we have Cassandra. It's a NoSQL database that very good. I think it's in most scenarios it's better than MongoDB. And also Twitter nowadays using Cassandra too much. Also Apple using Cassandra in its nodes too much. Many nodes of Apple now are Cassandra database. And here you see another database, is H2 database, that is a very lightweight in-memory database. Also here your Redis, that is a key value in-memory database. Redis is a very famous database that is a key value in-memory database. It's mostly using for caching data. Even in Spring we have a Spring Redis and a Spring cache abstraction that working very good, and it has been integrated with Redis. And also we have another product called Redis Sentinel, that is the clustered version of Redis. You can distribute your Redis node across multiple servers and cluster between them, and having some redundancy and leader elections between those clusters. As an alternative to Redis Sentinel, you can also use Aerospike, you can use Apache Ignite, or you can use commercial products from SAP HANA or IBM Data Warehousing. But Redis is very good. Also, we can use etcd from core OS in most scenarios instead of Redis Sentinel. Well, and as you see here, the Spring Cloud Spring Cloud config server is responsible for the configuration of your system. You may have different configs for your staging environment and your production environment. You may dispatch your configs for staging and your test environment to one place, for example, Git repository, and for your production environment to another place. And as I told you, history dashboard here is responsible for circuit breaker. Eureka is responsible for discovering your services. Here you see the reservation client and client API. In this place you may have some iOS client, Android client, web client, IoT clients, maybe your refrigerator or your washing machine, maybe use here as use this whole system as an API client. And Okay, here you see an ecosystem of Zipkin. Zipkin is actually a distributor tracing system that here you see the Zipkin collector as responsible for collecting the metrics that that are related to your systems, and Zipkin query for querying it, and Zipkin web that is responsible its work as a dashboard visualizing your flow of data request metric of your system. I will show an example of Zipkin in other parts of this tutorial. Well, I think that this slide is very descriptive, and it is talking about itself. It's very good. Right. I am going to this next slide. In this slide, I wanted to focus on a ribbon client-side load balancing that is very interesting. You may be already familiar with other um, load balancing systems like using Nginx as a server-side load balancing, or some hardware in combination with Nginx and HA proxy for implementing load balancing. But here we have different approach that is client-side load balancing using Netflix ribbon. As you see here, we have different webs microservices, service 1, service 3, and this is another service. Each of them has been load balanced with ribbon load balancing between service 4, service 2, and the approach that Netflix use here as a client-side load balancing is totally different from server-side load balancing that I will discuss about this approach. I mean ribbon and net client-side load balancing in detail in other parts of this tutorial. Also here, as I discussed in previous session, you can use Zoom as API gateway, as you see here. And you may have an authentication server for having OAuth 2 for your security purpose, for generating access token, refresh tokens. You can use OAuth 2, or instead of OAuth 2 you can use other type of security layer here. For example, basic authorization, that is very simple to implement in comparison to OAuth 2, and both of them I suggest you that you use SSL for transferring tokens over the wire. Or in the cases that you are using basic authorization, if you don't use SSL, don't encrypt your authorization tokens, some hackers can sniff those tokens, and by using a man in the middle trick or other tricks, they can intrude your system and they can hack your system. So in whatever security you use, it would be better that you use them in a secure network, using for example SSL. And here we have database DB1, DB2, that as I discussed about the polyglot approach persistent, maybe DB1 MySQL and DB2 Cassandra. And here, as you see, API gateway, you have Zool, and different kind of clients we have here in this layer. You have web application, mobile application, maybe Android, iOS, Windows application, and third-party integration, maybe other system, another monolithic system for another company, another microservice project for another company may want to use your system, so they come to API gateway. The API gateway is responsible for proxy-based routing, for disseminating routing to your service, conversion, etc. all these will be handled in this layer, so your internal and author architecture of your microservices are not engaged and worry about these issues. So API Gateway handle, it is like a bridge here, handle all the requests here and also response to your from client and to the clients. And here you see a very simple hexagonal image here that basically it simply illustrate what I have discussed already. You have in this example you have two services. In this hexagon you see recommendation service and movie service. In this hexagon, I mean green hexagons are your two different services in this example, and you have a yellow hexagon here and blue hexagon here. These are part of your author architecture in your microservice environment. The blue one is configuration service. I discussed about it, and I gave you an example. For example, a string configuration service that is responsible for separating configuration in the environment instead of being in your project or in your services. And here you have discover a service. For example, as I discussed already, you can use Eureka from Netflix for discovering your services. So recommendation service doesn't know anything from movie service directly. By using discover service, recommendation service and movie service and vice versa will be noticed, will be knowing that they all exist and how to communicate with each other. Okay, I think this image is very descriptive, and I have discussed about all these parts separately in many slides. Here, as you see, we have a 12-factor methodology that you can search in internet. It actually has 12 factors discussing about very important 12 principles and some roadmap, some suggestion that it would be better that you adhere to them in your implementations. No matter you are using a monolithic system, SOA architecture, or microservice architecture, most of them can be implemented and can be used in your system. Maybe you have monolithic SOA or microservices. But configuration service, as I remember, is the third part of the 12 factor. It says simply that the configuration, instead of being in your project, should be stored in the environment. So it is very important. And also you can have different configuration for your project. For example, you can separate your configuration for a staging environment in some place, and for your production environment in another place. And you see that I have referred here to this site. You can check all the other factors in 12factors.net. Well, here you see configuration service that here in the left part of the slide you see the staging environment that has a staging configuration that has been hosted and will be maintained version in Git repository. And here you see production configuration. It also has been hosted, maintained, versioned in a Git repository. For example, in GitHub, you can use your local repositories. You can use also Bitbucket, GitLab, or etc. Some other type of Git-based website or local-based Git applications. But GitHub, Bitbucket, and GitLab are very good choices you can use for managing, maintaining your configurations. Well, I'm going to another slide I have discussed about discovery uh, in other part of this tutorial. You can use uh, Netflix Eureka Discovery Server for the means of discovering your services. It's for example, you don't need to hardcode the port of an IP, the list of ports and IP of all of the services in your services in order to be aware of the services. You can issue requests to the service discovery for updating the list of the services that you can call them. Whenever a service come into play, it will register in discovery, and all of the services will be aware about it, and you can use the discovery server for sending requests to another service. For example, one service registration to another service recommendation, and vice versa. And as you see here, Splunk Cloud Feign is a very good library for client-based API for RESTful in microservices, that I will show you codes how to use Spring Cloud Feign as a client-based API. You can also use a Spring REST template for issuing REST calls from one service to another service. But Spring Feign is also another good alternative in this case. Recommendation. Here we recommend that you use Netflix Eureka, and also in combination with Consul from HashiCorp. For example, you can when you are using multiple discover services, you can use one of them for DNS provider. In this case, you can use Consul from HashiCorp for DNS provider, and another one here you can use Eureka as a proxy-based API gateway. So it will be a very good combination of using Consul and Eureka discovery. Well, and here you see an example about the Feign client REST API. I thought that I will describe it here. The Feign has been developed by Netflix. As you see here, it's very easy. It's very easy to implement some interface that are responsible for calling some API endpoint. This interface has been annotated with a Feign client that is actually wrapping a movie API endpoint. Here you see that this one is a endpoint that calling movies with a HTTP get method, that this method finding all movies. It's very simple interface here. And also this one is another API for calling and endpoint. Here it is a movies with a path variable ID. For example, you want to search movies with ID 1 2 3 4. You can use this method find by ID. That here a request parameter has been mapped to a variable string ID. It is very simple. And here you see something similar to this one, but the HTTP where here differs. Here you have get and here you have post. So, and also you have mentioned here it produces application JSON. As you see, in your response, you may have application text, you may have JSON, XML, UTF-8, etc. I mentioned here it produces application JSON and create movie. So it will uh, get a request body that will be data regarding a new movie that should be created in database, and you call this create movie. Okay, friends, I think that that's enough for this part, and I will continue to create uh, other parts and other complementary parts for microservices architectures, and I request you check my YouTube channel on and on to find my new tutorials there regarding microservices, regarding multi-threading, and etc. Thanks for your time, friends, and thanks for watching my tutorials. And I wish you a very good day or night. Take care and bye bye.